mode.
Good evening, everybody, and welcome to another episode of vBrownBag US. This evening, I'm very excited to have Jase McCarty with us. He's going to be doing some talking about vSAN design and sizing. Before I cut it over to him, though, let me do a couple of housekeeping rules. Please get in on the conversation. Let us know how we're doing. You can always reach us at the Twitter hashtag @vBrownBag. If you want to do any live questions this evening, if you're in the audience, you can send me a question via the chat panel, or you can do hashtag vBrownBag, and I will get those questions as well. So without further ado, let me turn this over to the man. Jase, how are you doing this evening?
The man. Well, I will say I've got a bit of a cough, so I'm going to do my best not to destroy everybody's ears.
Oh, geez.
As far as that goes. So, but glad to have everybody on. Definitely really like to share this content. I will say this is a kind of a repeat, if you will, of some content I gave a couple weeks ago. And let me try to figure out how I can minimize this and see. All right. I don't know if my screens are showing up or not, but
oh yeah, we can see it. vSAN design and sizing.
Okay, good. All right. So, pardon me. Again, I apologize for the cough I've got. I would have taken my my medication, which has got an odd name to it. It's called Ninja Cough, which I kind of laughed when I saw that. N-I-N-J-A-C-O-F is actually the name of the cough medicine that they prescribed for me. So, but with that being said, let's go ahead and get started. And big thing to keep in mind when it comes to vSAN is how is it different than traditional systems, right? Traditional storage systems, right? Now this slide I think is going to populate on its own, but if you notice, we've got some capacity being presented up on the left and some applications and whatnot. We've got multiple shelves with a combination of solid state drives and SATA drives and nearline SAS with some cache and whatnot, right? Now if we look at the way this is laid out, it's essentially multiple controllers, multiple shelves. We decide that we want to grow things, we've got a, it's not necessarily as straightforward. Different, I'll say different legacy systems as far as, the amount of RAM you can put in a, let's say in a controller, amount of cache you can put in a controller, the number of drives you can put behind a controller, different things like that all come into play when it comes to traditional storage. And vSAN is a bit of a departure from that. Now, this is probably a standard slide everybody's seen. I'm not going to dwell on it, but the big thing about vSAN is and I don't want to, keep this marketing-ish. I want to really get into the weeds, so I'm going to move fast. But, anything that we support as far as the vSphere HCL and couple that with some vSAN certified components, we can run vSAN on. Now, we pull local solid state and capacity drives. When I say capacity, that could be solid state or could be spinning. And my favorite part really all about vSAN is the fact that we're using per VM storage policies. So this is where you hear me repeatedly say and hammer it down over and over again. SPVM. Storage policy-based management is the absolute best thing to me when it comes to vSAN, because it gives us the capability of individually custom tuning the either protection or performance or whatever other property that we're exposing up to the stack for any individual part of a VM. That's the thing I love the most. And then in conjunction with that, as we're really deeply integrated into the stack. So some people would say in kernel, I like to think of it as native, right? So vSAN itself providing storage services up to the VMs, it's natively part of vSphere, right? So it's not like we're using a VM that is consuming storage and then presenting that storage up to VMs to be consumed or up to hosts for VMs to consume. It's essentially native presentation of storage up the stack, if you will. All right. Now, whoops, wrong way. Now, important thing to keep in mind is when it comes to vSAN, again, it's not necessarily like traditional storage. Now, if you want to talk about object storage, it's similar to that. But what I'm getting at is vSAN itself is an object store. Each individual object is going to be made of multiple components. Now, if you notice in this particular illustration, I've got a VM, I've got a RAID 1 mirror, and then I've also got some RAID 0 in place with some stripes.
Bless you.
And if you notice, thank you. If you'll notice, though, it's per VM. It's like per object. It's not like I am doing this for an entire data store, if you will. Hey, I just figured out how to hide that whole little thing, that GoToMeeting thing. That's awesome. All right. Let me get back on track here. So the big thing to keep in mind is when it comes to the way that we lay data out in this particular configuration, this is a 2-node config with a witness host. And in this particular configuration, we have a policy that says I can only do mirroring as far as a protection scheme. And the reason I can only do mirroring is because I've got 3 fault domains in this particular case, right? So I've got a fault domain on the left, fault domain on the right. I can stripe things wide if I want within each of those fault domains, but then at the same time I have to have that witness component. And it's important not to get witness component confused with witness appliance, and we'll cover that at some point. But long story short is if we look at any individual object on vSAN, we have to have at least greater than 50% of the contributing pieces available for that to be accessible. With that being said, if I only have the piece on the left, that RAID 0 piece, if you will, that's got the 2 stripes, in conjunction with the witness and the other host is gone, I can still operate. All right, if I lose the witness component and I lose another host, then I can't operate. Now I haven't lost my data, it's just not accessible until those pieces come back. So let's move a little bit further and kind of do some comparisons, right? Traditional storage on the left, please feel free to take a screen capture of this particular slide. I'm not going to go through every individual one, but the important thing to keep in mind here is vSAN compared to traditional storage. There's a lot of things that we do similar. There's some things that we do a little bit different, but we've got pretty much anything and everything that traditional storage provides to a certain point. Now, with that being said, traditional storage is either going to present storage for the consumption of vSphere either by file with NFS or by block using iSCSI or fiber channel with the VMFS volume on top of that, right? So with vSAN, we're not really providing file services per se. We're not providing block services. Well, we weren't until 6.5. 6.5 we introduced support for iSCSI in some use cases. But long story short, the big difference to me where traditional storage and vSAN differ is the fact that traditional storage, I've got to individually go in and carve this entire array up in such a way that it's very rigid and it's very hard for me to move things around without having to have a lot of space to transient space to move things to an alternate location while I make some changes and that kind of thing. Whereas vSAN, we simply change a policy on a VM. Right? So again, I'm not going to spend a lot of time on this particular slide. All right, vSAN, another great things about it is I know when I was a storage customer, I would go and I would, every couple of years I'd have to start investing in trying to figure out what new array I was going to add. Was I going to add another EMC array? Was I going to add another NetApp array? Was I going to add another IBM array or HP or Dell or whoever, right? And then as I made those decisions and tried to figure out which was going to be best as far as price and features and whatnot, as well as the architecture that next platform would support, then I'd have to think about a migration plan and so on, right? But with vSAN, because we're running natively on top of vSphere or on top of the same hardware, if you will, that vSphere is running on, the only thing that we have to do is upgrade vSphere. And we've got the next version of vSAN. So as our normal life cycle changes, as we go from, I'll say, Dell Generation 12 servers to Dell Generation 13 servers or 14 servers or 15 servers or so on, or HP Gen 8s to Gen 9s to Gen 10s, whatever. It really doesn't matter because it's all built into vSphere, right? It's natively part of vSphere. And as vSphere supports additional hardware, vSAN will support additional hardware, all the new stuff. And we literally just migrate our workloads over from older hosts to newer hosts. So all the new stuff as it comes, we're always working to make sure that we support it, right? So it's not really as much of a traditional, hey, let me do a forklift and migrate everything over type perspective. I have some poll questions. I'm going to skip through these. I forgot I had them in the deck, but really the meat of tonight is really some of the design considerations specifically around vSAN. First and foremost, something that's very, very important to keep in mind, boot devices. Pardon me. You notice here I've got a couple different ones listed, USB, SD card, SSDs, or SATA DOMs. I'm not going to go deep into each of these other than to say it's pretty obvious which ones you're probably going to want to use. You're probably going to want to use a native SSD drive, or you're going to want to use a SATA DOM in most cases, especially if you've got, let's say, hosts with more than 512 gigs of RAM, right? Important thing to keep in mind is our SSDs and our SATA DOMs have a much higher endurance. So if we're doing any type of logging, if we want to store logs, those types of things, they're really better on either SSDs or SATA DOMs. SSDs are really not, super expensive. You can get very, very small ones which are appropriate for this. I know in my house I've got some, I'll say consumer grade 200 gigs, for my little lab. But SATA DOMs, as an alternative, are going to be a good bit more expensive. They may not necessarily be as large, but they're dedicated. Now, SSDs are typically going to take up another slot in a chassis, which might be a slot you want to use for capacity or another cache device or something of that nature. SATA DOMs are typically not going to consume an additional slot, and as a result are going to give you more capacity as far as the chassis goes for additional either cache devices or capacity devices. Okay, and Chris, if any questions pop up, please feel free to jump in and let me know.
I certainly shall.
All right. Pardon me. All right, storage controllers are one of the most important parts, specifically when it comes to vSAN. I'll mention that there are two modes that we support, and it really depends on which controller, and it really depends on which architecture at the same time as to which mode we're going to support. Right? As an example, in my lab, I've got some 9361-8i Avago LSI controller cards. Right? I don't believe they're supported with 6.5 yet. They're supported all the way up to 6.2. And the interesting thing about these cards is these cards, they're 12G cards, but they're not supported in JBOD or pass-through mode if I'm using an all-flash configuration. If I'm using an all-flash configuration, I have to individually present each of my devices as though they're a RAID 0 device. So in other words, RAID mode. But if I'm using hybrid, because I don't have as high of a queue depth requirement, I can present them as pass-through. So important thing to keep in mind specifically when it comes to the storage controller is the storage controller is they're each storage controller and each build of vSAN in conjunction with what architecture you plan on using are going to have potentially different either firmware releases or supported configuration modes, right? Now, we do recommend, if you notice on the fourth line, firmware drivers, we recommend that they need to exactly match what is on the vSAN compatibility guide, all right? I've seen cases where people have upgraded to a newer version firmware and have had unexpected results. We basically say, if this firmware is what we have listed as certified, this is the one you need to run, okay? Now, I'm going to back up a little bit and talk about SAS expanders a bit. SAS expanders are also part of a particular configuration where we have to validate. So it could be that the controllers that I have only support natively 8 devices. I can expand them with a SAS expander. However, depending on the firmware of that card, the manufacturer of that card, the driver with that card, different things, I may or may not be able to use a SAS expander with an expected level of results. Where this is important when it comes to design and sizing is if I choose a card that doesn't support a SAS expander, but I have a need for, let's say, 16 drives, in my particular case, I would have to have 2 cards, right, in my particular config. Now, I will say this little last item, do not mix controller mode for vSAN and non-vSAN disks. What this basically means is if we're running a combination of, let's say, our boot devices off the controller as well as our vSAN disks. If we're going, let's say, RAID mode, then everything needs to be presented as RAID mode. If we're going with JBOD, everything needs to be presented as JBOD, right? So it again, really all depends. Now, single controller versus multiple controllers per host, that kind of really falls on the question of the capabilities of the card. Are SAS expanders supported? How many drives do I need? What's the queue depth of the card? A lot of different things come into play when it comes to what the best selection is as far as one controller, more than one controller. Does the board support 3 controllers, whatnot, right? It's really kind of a little bit of this, a little bit of that as far as that goes. All right. Now, We really recommend, if at all possible, and we typically try to validate any controllers in pass-through or JBOD mode first and foremost. It makes it a lot easier, a lot simpler when it comes to presenting a drive up to a host. We typically don't need any type of cache. If we're doing RAID mode, then we're probably going to have some type of cache in some cards. And I don't mean cache for the purpose of of adding any acceleration or whatnot, but some features may only be available to a card if, let's say, a cache module is available. In other words, I've got a card, it doesn't have a cache module. As a result, this feature is not even enabled, right? That type of thing. Or we don't have an appropriate queue depth because we don't have a cache module. Different things like that. But again, JBOD is much easier. As a vSphere host sees the drives, it's going to see the drives for what they are 100%. And what I mean by that is if a drive is solid state, then it's going to see it as solid state. Whereas if I'm in RAID 0 mode, I may not see that drive. I'll only probably see, like on my host where I'm running all flash and presenting them up as RAID 0, I'm seeing them as traditional drives. I have to tag them as being flash. Oops. All right. So it's a little bit easier when it comes to the overall configuration when it comes to using JBOD versus RAID. But entirely up to you. Some of this can be scripted. In fact, I'm working on some Power CLI for Store CLI with some automation stuff I've got kind of in the works, which can help with some of this as far as large deployments go. All right. Now, I'm going to get into some of the architectural differences between hybrid and all-flash. Hybrid caching for hybrid and caching for all-flash are completely different. Now, with that being said, up until 6.5, if you had all-flash hardware, we required an advanced license. In 6.5, we said, hey, we don't need that anymore. If you want to, let's say you've upgraded to 6.5 license-wise, but you want to do a downgrade to run all-flash on 6.2, you can, right? I've seen cases where customers in the past have had standard licensing with all-flash hardware, and they had the challenge of presenting capacity disks that were flash up as though they were traditional spinning drives, and that's really not the way to do it. Important thing to keep in mind is that caching algorithm is completely different from hybrid to all-flash. And sizing is a little different as well, and I'll get into that in a moment. But when it comes to hybrid, 30% of that cache is for writes and 70% of it's for reads, whereas all-flash, 100% of it's for writes. So I'll get more in depth into this in just a moment. Capacity devices, either enterprise magnetic drives or enterprise flash drives. I've had people ask in the past, hey, I don't see any more traditional spinning SATA drives on the HCL for vSphere 6. Don't see any more SATA. Why is SATA not there? Well, we've just really found that SATA was just not appropriate. Now, I've seen some cases where some nearline SAS are available. However, those are really still kind of the same drives as SATA drives with just a little bit different interface in the front of them, if you will. I will argue, though, when it comes to sizing, once you add things like the advanced or enterprise licensing, you use all-flash hardware. Once you employ deduplication and compression and erasure coding, some things that are only available with the advanced or better license, you may end up coming out cheaper, right? So keep an open mind when it comes to sizing. Now, specific to that hybrid versus all-flash with advanced licensing is really what this should say. We do support both mirroring and erasure coding versus only mirroring on hybrid, all right? Now, with that being said, pardon me, mirroring can be very expensive when it comes to capacity requirements. So when I go to size my environment and I'm using hybrid, I need to keep in mind that I'm going to require double the amount of capacity of my usable. Right? So what I mean by that is if I have a 1 gig VM, I'm going to need 2 gig to protect it. Now, keep in mind where vSAN is different than traditional arrays. Traditional arrays, we would do the mirroring on the back end. We don't do it on the front end on a traditional array. On vSAN, based on our policy, we do it on the front end, right? Now, our all-flash environments with advanced licensing and our enterprise licensing, not only do we support mirroring, but we do support erasure coding. Erasure coding with one protection, or one level of protection, so FTT1, gives us RAID 5, which essentially gives us about 50% more usable capacity, okay, than traditional mirroring. If we're using erasure coding, or if we're using erasure coding with failure to tolerate of 2, the ability to survive from 2 failures, that's essentially RAID 6. And with RAID 6, we actually get about 100% more capacity compared to the same level of protection with mirroring, right? Now, data reduction in all-flash advanced enterprise editions, something that's important to keep in mind when it comes to data reduction in vSAN is that data reduction is on a per disk group level, okay? And I haven't really gone into the construct of a disk group, but a disk group is a cache device and between 1 and 7 capacity devices within a single construct, okay? We do our deduplication and compression within the confines of that construct of that disk group. Now, that being said, if I have 3 hosts with 1 disk group each, then I'm essentially deduplicating and compressing in 3 different locations. Now, depending on what your workload is, if I have a lot of the same, if I have a lot of, let's say, like a development SQL farm, and I've got tons of SQL with all the same data, and I've got copies and copies and copies and copies, I'm probably going to get a really good deduplication ratio, right? I mean, that's just the way that goes. What's important to keep in mind is, and just from my time, both being a customer as well as working with federal customers when I was at my previous position, I always, and I was also in financials for about 5.5 years, and we always designed for failure. One of the challenges of a traditional array with a single deduplication, I'll say deduplication across an entire cluster or across multiple aggregates or whatever. Important thing to keep in mind is if anything were to occur, any type of corruption would occur to that deduplication metadata, then we could potentially lose a large amount of data and have to recover from backup. The great thing to me when it comes to the way we do deduplication and compression with vSAN is we're isolating it per disk group, and if we did experience, which we haven't, any type of corruption within a disk group, then it's not going to affect the rest of our environment as far as our data integrity goes, right? So it's a trade-off. We may or may not necessarily get the same consolidation ratios, but we've got a little bit more security, I think, when it comes to the way that we do deduplication and compression in comparison. Now, these are turned on together, turned off together. There's not really any supported way to be able to run one and not the other. And we found that the overall overhead of both of those is about the same. So if you were to, from an engineering perspective, only enable one or the other, the overhead would be about the same. And those two guys, in conjunction with checksummings, like 2 to 3%, something like that, additional CPU overhead. Now, as far as networking requirements go, pardon me.
Quick question about dedupe and compression.
Sure.
If your disk array already comes with dedupe and compression, does vSAN recognize the dedupe, or is it before it hits the array?
Okay, let's see. Let me see if I can get my head around the question.
Yeah.
So if your existing array already has deduplication and compression.
Yeah.
Okay,
Does
wait.
vSAN recognize the dedupe? Or I'm not sure if he's talking about the card or if he's talking about something else.
I'm not sure as far as comparing vSAN to an existing array. Now, we'll say that let's say you did see a fair amount of deduplication savings on an existing traditional array, and then you migrated that workload over to vSAN. Depending on how the data fell, depending on how many disk groups you have, depending on how much capacity requirement there is and whatnot, you could potentially get more or less of a consolidation ratio in comparison. It just really depends. And to give an example, I've got 2 hosts, in my lab or in one of my labs that have 1 disk group with 1 cache device and 2 capacity devices, and I loaded up. I want to say I had probably 200 VMs at one point across these 2 hosts, right? So 100 VMs per host. Now keep in mind, I only had a single disk group, and it was essentially copies of copies of copies of copies of copies all residing on the same. I had a deduplication ratio of like 25 times. It's like, hey, I need to show these hero numbers. This is awesome, But it wasn't really realistic, right? And the reason I would say it wasn't really realistic is I probably wouldn't, expect a customer, try to tell a customer to expect that, right? I would give more of a realistic expectation. You've got this many VMs, you've got this many hosts, and you're going to have this reasonable amount of deduplication and compression across. We typically say between 2 and 7%. You add that in conjunction with erasure coding, some of the savings there, and I've seen some I'll say conservative numbers of upwards of about 10 times, right? So it really all depends on the workload, but I'll be honest with you, when I saw 25 times, I was like, hey, I got to show somebody this, right? But again, those were hero numbers, and they weren't really realistic, right?
Gotcha.
So with that being said, network requirements, hybrid, we have to have at least a dedicated 1 gig NIC, or you can use shared 10 gigs. All flash, we require shared 10 gigs. Now, with that being said, and it's not on this slide, but vSAN includes VDS licensing. So if you've got vSphere Essentials, if you've got vSphere Standard, vSphere Advanced, vSphere Enterprise Plus, whatever, it doesn't matter what edition you've got, you're entitled to VDS. With VDS, we have the capability of leveraging network I/O control. So like in my lab where I've got 2 10 gigs in a direct connect configuration, I can go and I can carve these guys up where this much of it's for vSAN traffic and this much of it's for vMotion traffic and so on. Now I've had people ask, hey, is 10 gigs really going to be enough? Do I need a dedicated 10 gig for vSAN? In most workloads, in fact, I don't think I've run across a particular situation where 10 gigs wasn't enough and bandwidth was saturated, right? That's not to say that it couldn't happen, right? It really all depends on what the workload is. But I've worked in some fairly large clusters that have had a fairly large resync operation going on, or multiple resyncs going on simultaneously, and I've not gotten to the point where I've saturated a 10 gig link, right? And we'll cover some more of this as we go a little bit further. And I'm going to have to speed up because I want to make sure I get all this. Now, this next particular item that I put here, potential I/O, in a workload that was hybrid, I forget how many capacity drives we had that had 2 disk groups. In a particular configuration, we saw 40,000 IOPS per node. So on a 3-node cluster, you could say 120,000 IOPS, hybrid, right? And all flash, it's 150,000 IOPS per node. I want to say this was a dual disk group. I don't recall how many capacity devices were in the cache tier, or how many capacity devices were in the capacity side of the tier. But my point is depending on the type of workload, whether it's, let's say 4K 100% read, 4K 70/30, whatnot. I'll get into those in just a moment, some of those numbers. But important thing to keep in mind is the number of hosts you have, the number of disk groups you have, the types of devices you have for your cache devices. All those are going to play a factor in the amount of I/O that you're going to be able to achieve out of a cluster, right? Now, we've kind of covered this specifically about the type of devices. Flash in a hybrid config, it acts as that buffer, or buffer and read cache, right? So 30% of, let's say, a 2 terabyte cache device, 30% of that, 600 gig, is going to be a write buffer. The other 70%, 1.4 terabytes, would be a read cache. Now in all flash, on the other hand, the entire drive becomes a write buffer. We don't do any read caching in an all flash config on that cache device. Now, some people have brought up a technical point in the past where, hey, you've got a 600 gig, quote, partition, if you will, that we use for that write buffer. Important thing to keep in mind is, and I think my next slide kind of covers it. No, actually 2 more slides, but I'll get to it. Important thing to keep in mind is if I have let's say an example, if I have a 600 gig cache device and I have an 800 gig cache device that presents 600 gig, or I have a 1.2 terabyte cache device that essentially presents a 600 gig buffer, if you will, write buffer. That 600 gig device, once it's full, it's got to do garbage collection, it's got to do cleanup, it's got to do maintenance. That 800 gig, once I hit the 600, essentially that I'm presenting externally, I've still got room internal to the drive to continue to write capacity, right? I'm not doing garbage collection yet, not till I hit that 800, right on the 800. On a 1.2 terabyte device, I've essentially got double the space to write before I even begin to think about doing any garbage collection, right? So a lot of people kind of get wrapped around the axles when it comes to that old number of 600 gigs being some kind of limit, but it's really not, in the fact that the larger the device, and on top of that, larger devices are always going to have larger devices within the same class are always going to have a much larger I/O capability. I know I was looking at drives the other day, and the 200, 400, 600, and 800 essentially went up in order. It went up linearly as far as the I/O per drive, right? So important thing to keep in mind is, and we'll see it in about 2 slides, kind of what we need to do as far as all flash cache, all flash sizing, cache sizing for all flash. There we go. I finally said it. Now, hybrid, we haven't really changed our rule of thumb. We typically say that, pardon me, the total amount of cache size that you need is going to be 10%, right? So if I have 20 gig VMs, I'm going to have 1,000 of them. I'm going to take up 20 terabytes. I need 2 terabytes of that to be flash, so 10%, right? Now, if you think about the way vSAN lays data out, remember I was talking about mirroring previously. So if I'm going to consume total of 20 terabytes, it's really 40 terabytes I'm consuming. And on a 40 terabyte config such as this, I only need 2 terabytes of cache. All right, so it's essentially 10% of what I'm going to use for hybrid. That's pretty much the gold standard, if you will. Right, so 10% is a general recommendation. Could be too much, or it may not be enough, but as a general rule, that's kind of where we start. Now, we've kind of changed our guidance on flash or cache sizing for all flash configurations. It's really around the number of writes per day, what total capacity is written per day, different things like this. What are our sustained writes and so on? And I'm not going to get wrapped around these. Feel free to take a screen capture of this if you like. But in general, the guideline, to give an example, so if I have a 70% read, 30% write, and it's random, let's say like a VDI or like a low-use VDI or whatnot, what we would call read-intensive. If you're going with the largest tier, all-flash 12 or all-flash 8 ready node, then you'd only need about 800 gigs for that particular tier. All right, we get about 80,000 IOPS. Now, at the same time, if I'm doing 100% write sequential, let's say I'm writing video or doing some type of large data dumps or whatnot, just 100% write sequential, I'm probably going to need to double that. All right, I'll still see about the same number of IOPS, but I'll probably need to double that because my workload profile has changed. It's changed from only 30% write to 100% write. Right, and this is a current slide. This information is also on virtualblocks.com, specifically calling out the what and the why. I would say most medium use, workloads, general server consolidation, things like that, I'd probably go middle of the road. I'd go with that greater than 30% write. I'd probably, on my largest environments, I'd go with at least a 1.2 terabyte for my cache device, or 800 gig for, expecting 50,000 IOPS per host, that type of thing, right? And this is per disk group, right? So keep in mind, we can have up to 5 disk groups in a host, provided the chassis supports it, right? All right, any questions so far?
No.
All right, now, like I said before, we talked about traditional spinning drives. SAS and nearline SAS are supported. We're not supporting any more SATA magnetic drives. It's just not happening. You're probably not going to find any 15Ks on our VCG either. We see a little bit of 10K, but by and large, most of the customers that I see and that I talk to are using 7200 RPM drives. Now, keep in mind, with hybrid, we only support mirroring. We do not support erasure coding. However, with that being said, in some cases, depending on the type of data and whether you're worried about deduplication and you're worried about more than the ability to protect from more than one failure, you may run across a less expensive configuration if you go hybrid with 7200 RPM. I would dare to say, though, that the cost of what they call read-intensive solid-state drives in conjunction with deduplication, compression, and erasure coding, you may get a run for your money as far as going the traditional route versus flash drives. And flash drives require less power. They're a lot easier to manage than traditional spinning drives, right? So that's all I got to say about that. By and large, and I'm not trying to tell anybody you don't even consider hybrid. I would say hybrid is probably I would look at all flash first before I ever looked at anything else before I looked at hybrid going forward. Okay. I talked about disk groups very, very briefly. Disk groups, we can have up to 5 per host, up to 7 capacity devices per disk group. That means that we're going to have up to 5 flash devices and up to 35 capacity devices, either traditional spinning or solid state. And it really all depends on what the chassis will support. So if you have a chassis that supports 40, you can populate every one of them, provided you've got enough, let's say controllers and bandwidth on the controllers, that type of thing, right? You may not need that though, right? Now at the same time, with disk groups, we can have a host that has multiple disk groups. We can bring one disk group offline, do maintenance to it, either grow it, change it, add more capacity. I mean, in some cases we can add while we're running. It really depends on whether we're using deduplication and compression or not. But important thing to keep in mind is that I had a customer not too long ago that bought vSAN very recently, or I say recently, about a year or so ago, and they had someone approached them with a really good deal on some new drives, and they said, well, we've got 1 terabyte capacity drives now, but it looks like we can get a really good deal on some 4 terabyte capacity drives. What do we do? And these were, these were traditional spinning. And I said, well, with vSAN, you can just bring a disk offline and swap it. Take the one terabyte out and put a 4 terabyte in, right? It's not like I used to have to do back in 2005 with an old IBM Fast T700, where I had to wait until I changed all the drives in a DAE from 73 gig drives to 146 gig drives, right? I didn't have to wait till everything was the same. I mean, I did have to wait till everything was the same, whereas now with vSAN, we really don't have to do that. We do recommend a balanced configuration, but you can absolutely, and it is supported, run with some mix and match. Important thing to keep in mind is the behavior, data layout, and whatnot may not behave as uniform as you might think as you're transitioning, let's say, from an older, smaller drive to a newer, larger drive, that type of thing. Okay. So here's kind of a...
all right, quick question.
Yeah.
Is there a specific use case wherein a hybrid vSAN would be a more correct choice than an all-flash SAN?
I would say so, yeah. I mean, it really depends. I mean, if let's say, for instance, I don't know of any specifically that we've got on the HCL, but let's say, for instance, I've got I'll just pick a drive size of, let's say, 6 terabytes, right? So let's say I've got a 6 terabyte drive capacity for spinning versus, let's say, a 2 terabyte capacity drive for flash on, for the capacity tier, and I'm not worried about deduplication and compression, so I'm going to use mirroring regardless. Or I'm not worried about deduplication and compression, but I do want to use erasure coding. It could be that the numbers actually work out to be about the same, or it could work out the numbers are cheaper if I go with spinning, if I'm doing 7,200 RPM drives as opposed to 10K RPM drives. So that's just one use case. Now it really depends on what your individual requirements are. The important thing that I try to remind people when it comes to technology changes specific to disks is, as traditional spinning drives get larger, their I/O doesn't keep up with their capacity. So while I can today fit, let's say, in the same geography, I can fit 8 terabytes, that previously I could fit 1 terabyte, that 8 terabytes is going to be about 1/8 as fast as the 1 terabyte was, right, if you think about it. So when it comes to operations such as rebuilds, when it comes to things such as decommissioning a host or decommissioning a disk group or different things like that, quite often the cost associated with the time waiting to either evacuate a disk or rebuild data or other might be better suited in purchasing all flash hardware as a comparison, right? So that's just kind of how I approach it. Now, pardon me. This balanced config that we have here, 4 hosts, we've got 2 disk groups. We're saying same of this, same of that, same of the other. I was talking with a customer actually yesterday, and they've got a pretty large cluster, in the 40s, over 40, mid 40 hosts, and they're in the process of doing some maintenance. I haven't covered this yet, but they've got some fault domains set up and whatnot, and I asked them how many fault domains they had, and they had like, I don't know, 6 or 7, something like that. And they're all flash. They're doing RAID 6, and they gave me a breakdown of all their fault domains. They had like one fault domain with 3 hosts, one fault domain with 9 hosts, and one fault domain with 6, and another one with 7, and it wasn't really uniform, and it kind of made it hard to judge when it came to doing, you know, operations and trying to figure out where data is going to lay out. Because as we write data, whether it be mirrored or erasure coded, we're going to write across our fault domains, right? We're not going to write within a fault domain, we write across them. And in that particular config, there were cases where one fault domain could potentially, you know, the 3 host one could potentially fill up, and the other fault domains then were required to, you know, to be available to meet the policy requirement. So important thing I'm trying to really hammer home and make sure that everybody understands is, you know, a balanced config is really your best bet overall as far as, you know, day-to-day operations, meeting policy requirements, maintenance, different things like that. Now that's not to say that you can't have an unbalanced config. You know, it's how many customers out there going by 4 nodes that are, I'll just use an example. Let's say, you know, last year I bought 4 Dell R620s, and then this year I want to expand it and I buy 4 R630s. And they're a little bit different, and the drives are a little bit different. Is that supported? Absolutely. We will support that, right? But the important thing to keep in mind is you probably want to keep it as uniform as possible, right, to a point, just to make it a little bit easier on you. All right, so I'm going to step into networking a little bit and go and populate these guys out. Pardon me. So these are some of the myths, and this is, I don't know who this guy is on the right. I forget whether it's Aristotle or who it is, but
it's Mythocrates.
Mythocrates.
Sorry.
John Nicholson. John Nicholson had somebody here. I forget who it was, but I went in there, kind of cleaned up the slide a little bit. But the important thing to keep in mind today is we do have a requirement for multicast for only the vSAN network. Okay, and when I say the vSAN network, just the VM kernel interfaces that are talking to each other, right? So there's not any, you know, requirement to have a publicly facing, you know, multicast, you know, routed and whatnot network. There's not really a requirement for that unless you're doing stretched clusters, and you know, you've got a witness residing in, let's say, another location like vCloud Air or something like that. But multicast is really not that difficult. There are times when it can be difficult. I would highly recommend that you have a dedicated VLAN, and you have and you basically deploy it with layer 2. Don't try to do any multicast, you know, layer 3 routing, because it's a pain in the tail, right? You don't have to be a CCIE. It's not that difficult. I will say, though, that if you have multiple independent vSAN clusters operating within the same space, you probably want to either give them a different multicast address, and we've got a KB article on how to do that, how to change that on a different cluster, or give them a different VLAN. It's really not that difficult, you know, and I know we all know that all the networking guys love it when we say, hey, give me another VLAN, right? Tell you what, matter of fact, why don't you just go and trunk that thing, right? And I'll handle it on my own, right? We all know they love that, but the important thing to keep in mind is that you don't have to be a CCIE to get this working. It's not that difficult. Another big myth when it comes to the network is jumbo frames are absolutely not required. I talked to one of our, you know, one of our folks, you know, at one of our TAMs, you know, just Monday, and he's like, oh yeah, you got to have jumbo. I'm like, no, you don't have to have jumbo frames. He's like, you don't? No, absolutely not. You don't have to have jumbo frames. If you want jumbo frames, and you're comfortable with jumbo frames, and you think you can get a little bit more, you know, overhead, a little bit more performance out of it, absolutely, feel free to, right? But there is no requirement whatsoever for vSAN to have jumbo frames. None. Right? Now, it does say here, configure it anyways for NSX. If you're using the same switches, let's say the same BDS that you're also using NSX for, and we're not doing vSAN transport with NSX just yet. You'll probably use jumbo frames on the NSX side. But as far as the VM kernel interfaces for vSAN, unless you are 100% on jumbo frames across your environment, just leave it at 1500 and call it a day, right? Just leave it at the default. Now, another thing that's really important when it comes to the network, you don't have to have data locality, right? Now, you know, some of our competitors will say, oh, data locality is the best, and it's, you know, I'm not going to say that data locality doesn't have benefits at times, right? It does. In fact, we do data locality and what we call site locality in our stretch cluster configs. There's a reason we do it in those particular use cases, but data locality is not really necessary. We've found that it really doesn't help because when we're doing writes, we're already doing writes across the network. Anybody else that's doing mirrored writes is writing across the network too, right? If we're going to try to tie data locality to a VM, what happens if DRS says, hey, VM, you need to move somewhere else? Well, then I've got to move that data with that VM. Well, now I've got additional overhead on my my data network that I didn't want, I didn't expect. So which is easier? Is it easier to keep moving data around all the time and trying to play catch up with my VM, or is it just easier to to not even worry about data locality and use the speed of the network as it is, right? I mean, we're seeing that in pretty much every case, data locality is not an issue. Now, I mean, there are some corner cases, I'll say, where, we, let's say, for instance, like we're doing, big data or things like that, which we've got some mechanisms in place for that, but data locality is really, not anything significant that I'd be worried about as far as that goes. All right, so let's see. Oh, I did mention that we do include VDS. I'm going to have to speed up. I'm really behind. But I did mention that we do support VDS. We do include VDS in the licensing of vSAN. A lot of people will start off with a standard switch, but a couple things I really like about the VDS is things like network I/O control, the fact that we can see what our ports are advertising with, whether it be LLDP or the Cisco Discovery Protocol. And we do support additional load balancing mechanisms when we're using a distributed switch. If you notice at the bottom on this particular slide, so we can do what we call LBT, load-based teaming, where let's say every 30 seconds we go and we look at that particular link and we say, is this link full or pretty close to being full? Okay, I'm going to use the opposite one. Right? We can't do that on our traditional vSphere standard switch. We're just using either IP hash or virtual port ID. We've got a little bit more flexibility when it comes to using a VDS, right? So a vSphere distributed switch. Highly recommend using a vSphere distributed switch. All right, so let me kind of populate these guys out. Again, layer 2, layer 3 multicast is required. Highly recommend layer 2. Layer 3 multicast and the routing is a pain in the tail. You don't want it if you can get around it. As far as multicast, IGMP snooping enabled with a query enabled, or you can just disable it if you're using a dedicated non-routed VLAN for vSAN, right? And like I said a minute ago, ask your networking team, give me a trunk, give me a trunk. I know my networking guys always hated that when I was a customer, when I wanted a trunk. Now, network I/O control, I covered this very briefly. Keep in mind that network I/O control out of the box is not configured this way. But we can go, let's say if we look at an appliance that's got dual 10 gig uplinks, right? And let's say I'm only using 1 gigs for, let's say, something management or other, and I have everything running on dual 10 gig uplinks. I want to carve that traffic up. I don't want to ever get to the point where a vMotion operation from a DRS move or virtual machine traffic or whatnot is going to starve my vSAN network. That's where network I/O control comes into play and is very, very important. All right, I'm going to warn to be reserved, or be careful of using reservations, right? And don't use any limits. But if you look at the shared distribution here, 20, 30, 50, 100, that's kind of a good rule of thumb when it comes to what we need to do as far as carving up that 10 gig. Right? So essentially you have 200 total shares, half of it's going to vSAN, a quarter of it's going to vMotion, and the rest is for machine traffic and management traffic. Okay, now one thing I just want to cover with this particular slide, important to keep in mind, if you look at the particular, the two racks, we've got rack 1 and rack 2 with nodes 1 through 16 and 17 through 32 respectively. If we're in an environment where we're doing a lot of oversubscription, let's say we've got FEXs or something like that, keep in mind that vSAN is talking host to host, right? So I'm talking, let's say, host number or node number 1 to node number 4. I've got, let's say parts on 1 and 4, and let's say a witness component on 12 or whatever, right? I'm talking across each other, so I'm going to have to go up north and south to go east and west, right, to go across. So if I'm in a heavily oversubscribed environment, such as something like a Cisco FX type configuration, it's probably something to I'm not going to say avoid, but be mindful of, right, as far as that goes. You know, heavy oversubscription, you know, it's just something to keep in mind. If it looks like, you know, your traffic is you know, slower than it should be, you know, it could be that, you know, you're oversubscribed at this point, right? So just something to be mindful of. All right. I'm not really going to cover vSAN NSX. I want to stay true all the time. I talked about LODP and CDP. These are great, especially when it comes to you know, visibility from a vSAN level. But also keep in mind, when we've enabled this within network I/O control with vSAN, this also reports back to the switches. So this is a good opportunity for you as a virtual SAN admin to also present information up to the network admins. So the network admins have visibility as to what is connected to each of these ports, right? Really, really good networking tip. We do have some built-in proactive tests I'm going to kind of skip over. When it comes to sizing, when it comes to balance, when it comes to anything and everything as far as the health of a vSAN configuration, I highly recommend if you look at the cluster, look under monitor, and then click on vSAN. We've got a health check that will tell you anything and everything when it comes to the health of the environment. Are the drivers current? Do you have any inaccessible objects? Do you have, is the cluster not balanced? Different things like that. This runs every 60 minutes. It even has some visibility into use cases such as our stretch clusters. All of these can be tied to alerts that are presented up through vCenter itself. So any alerting, you know, alerting mechanism that you've already got in place, these will report as well, right? So there's not anything you have to do specific to that. Okay, whoops. So kind of some of the guidance around, you know, the hardware side of things specific to vSAN. And I think the rest of the slides after this are more about some of the ways you can consume it, which I'll get into in just a sec. But I highly recommend ready nodes. One big thing to keep in mind when it comes to ready nodes is people look at ready nodes and they say, I don't see a ready node with the configuration that I need. And when I say that, they say that, I say, what do you mean? And they say, well, it's got great CPU, it's got great RAM, but I need 2 more drives worth of capacity. You can absolutely do that. When you order a ready node, you can say, okay, look, I want to add some additional capacity. Or you can say, if the chassis supports it, I want to double the capacity. Things like that you can absolutely do. Don't let anybody tell you you can't do that, right? Ready nodes are a really, really good, easy way to consume vSAN, primarily because all the hardware is certified to work with vSAN already, okay? I mentioned use a balanced config. All right, I kind of didn't say this, but I say this about pretty much anything designed for availability as well as future growth, right? We never want to design something that's good for just today. We want to design for something that's good for the next 3 to 5 years, right? Depending on whatever our use case is, okay? I talked about SAS expanders. I talked about the VCG. Pardon me. It's really kind of the high level, right, as far as that goes. Now, some of the deployment options, some of these are kind of marketing type slides. I mentioned vSAN ready nodes. VxRail is another solution. I think we've also got another similar type product to VxRail from another vendor. Important thing to keep in mind is no matter what is important to you as far as the vendor of choice, if you like Cisco, if you like Dell, if you like Supermicro, Huawei, whoever your favorite server vendor is, we're probably going to have a ready node for you by them. So don't ever feel that the only choice you have when it comes to consuming vSAN is only Dell, or is only you know, HPE, or is only Intel or other, right? We've got 164, I think, total certified vSAN ready nodes across all the I forget how many vendors. I think it's like 16 or 20 total vendors, that type of thing, right? 15 server vendors, 164. There we go, right? You can bring your own licenses. Let's say today you get a great deal on HPE. 2 years from now you get a great deal on Hitachi. Great. You bring your license with you. You move your license over as you decide to grow, right? That's another one of the things that I've personally always liked about vSAN is the fact that when I go to migrate, and I had the conversation earlier on specifically about designing and sizing, where we have to design a new, pick up a new array, figure out how we're going to migrate to it, go through all that rigmarole. Whereas vSAN, let's say today I've got all Lenovo servers, and then I decide 2 years in, okay, I want to swap out to Hitachi. Well, then I can add a Hitachi server, decommission a Lenovo, add another Hitachi, decommission a Lenovo, add another Hitachi, decommission a Lenovo. And that's it. There's nothing I have to do beyond that, right? So it's not like I have to go and rezone stuff, and it's not like I have to go and migrate a whole line or move a whole file system or things like that. I mean, it's literally put a host in, add a host, let it contribute storage, put another host in maintenance mode, evacuate the host in maintenance mode, decommission the host in maintenance mode. So that's it. It's that simple, right? We're going to talk about Cloud Foundation. All right, so I'm right at the end of my time. Again, I want to thank everybody. That's joined. If there are any questions, I'm happy to stay around for a few more minutes and try to answer them. I've seen a couple things come up on Twitter, but I can't really do two things at one time. I'm too old-fashioned.
No, it's okay. Somebody's complaining about the Mythocrates joke. So,
oh, okay.
Yeah. No. No. Thank you. I mean, I'm sorry. Go ahead.
I'm thinking it might be Aristotle, but I really can't remember. It's been a long day.
Cool. Well, Jase, thank you very much for doing this. That was very informative. Is it possible to make the deck available, or is this a one of the VMware proprietary ones?
Let me take a look. I mean, obviously, anybody could take screen captures, and
right.
And this is a deck that we also presented in our Get More Out of vSAN series that we got going on right now. I should be able to share it. Let me just make sure that there's nothing like in the speaker notes or anything like that, and I'll be happy to forward it along.
Yeah, there was a request in the Q&A because we were going through some of the bigger screens pretty fast. If not, no worries. They can just rewind in here and take a screen cap from the video when we post it up.
Yeah, I don't really particularly see that as an issue, to be honest with you.
Cool, excellent.
Yeah,
well,
and I meant to put my name on this particular slide. Again, I'm Jase McCarty. I'm easy to find on Twitter. I'm Jase McCarty. On pretty much every social media platform there is, I'm Jase McCarty, that type of thing. Again, I work in the storage and availability business unit. My job is tech marketing for vSAN. Be honest with you, in 20 plus, almost 25 years of either being a customer or being a vendor, this is the best job I've ever had, and the product is awesome. Every time I turn around, our guys in engineering are just kicking out feature after feature after feature, and I couldn't be happier. I mean, a lot of enthusiasm. It's a great product and a great team.
Very cool. Awesome. Well, Jason, thanks for coming on again. I'm going to stop the recording.